starting to share my screen. Hope everything works out. Yeah, I'll just show the slides.
Yeah, excellent. Please start.
Yeah, thanks. So hi everyone, and greetings from Melbourne. It's like 6:30 p.m. here in Melbourne, and my name is Bo-Ming Xia, and I'm second year PhD student at CS Aerospace East 1, and also the University of New South Wales, based in Sydney, Sydney, Australia. My presentation today is about a mapping study we conducted several months ago, entitled "Towards Concrete and Connected AI Risk Assessment: A Systematic Mapping Study." So about the presentation, I'll start with the background and motivation of our research. So speaking of the background, of course, there is this the rapid development and advance of AI in recent years, or let's say the past few months, as we can know, like the ChatGPT and BARD. And however, associated with the development and advancement, of course, there are also concerns about the ability of AI systems to make decisions and behave responsibly. And also, there's also this kind of need to ensure that AI systems are developed and used responsibly. And this kind of like background or needs or requirements leads us to the concept of responsible AI, which is the practice of developing, deploying, and using AI systems in a way that benefits individuals, groups, and the society at large, while also minimizing the risk of negative consequences. The concept of responsible AI leads us to the need to, because concept alone is not going to take us anywhere too far. We also need to find ways to operationalize responsible AI. And one of the direction for operationalizing responsible AI is to identify, assess, and mitigate risks associated with AI systems development and use. And to achieve this goal, government organizations and government agencies around the world has developed various AI risk assessment and management frameworks in the past few years, which leads us to the objective and goal of our research to investigate the current status, including the capabilities and limitations of the existing AI risk assessment frameworks. And to do this, we have devised two research questions. The first research question is about the characteristics of the existing risk assessment frameworks, including the basic demographics, the responsible AI principles or ethics principles the frameworks aim to address or the framework covered, and also the stakeholders involved in the frameworks, as well as the scopes of the frameworks, including the AI lifecycle stages, and also the geographical locations and domains or sectors the frameworks can be applied to. Research question 2 is mainly about the processes for assessing the risks. So to this end, we have two sub-research questions. The first one is like the inputs to the framework, then the assessment process, and then the outputs. Before we go into the main results and findings of this research, I'd like to very briefly introduce our methodology for conducting this research. So basically, we follow the methodology of a multivocal literature review, and we went through the academic databases, including AC and IEEE, ScienceDirect, Springer, and Google Scholar. And we also searched the Google search engine with the same keywords listed in the slides. But then actually in the end, we only ended up with 16 selected frameworks from the Greek literature, considering the limitation, the limited scope and quality of the academic frameworks or the academic literature we identified. So this work is actually based on the 16 GRI literature or GRI frameworks we identified. So next I'll go into the results and findings of this research. The first I'd like to give you an overview of the finding, or let's say overview of the 16 frameworks, which are listed in one big table. So it can be a bit overwhelming. So just, yeah, give you a heads up. So as you can see in this slide, we have included 16 frameworks, 16 area assessment frameworks in this mapping study, including several relatively more famous ones, like the first one is published by the National Institute of Standards and Technology NIST of the US, which is named the AI Risk Management Framework, and the second one by the European Union, the Assessment List for Trustworthy AI, and the second one by the Canadian government, the Algorithm Impact Assessment Tool, just to name a few. Then, yeah, I'll just start to formally introduce our results and findings. Research question 1 is mainly about the framework characteristics, and research question 1.1 is about the demographics of the collected frameworks. And as we can see from the figures on the left side, we can see there is a growing number of AI risk assessment frameworks worldwide published in the last few years, especially in the year 2022, last year, which indicates an increasing global concern about the risk associated with AI, and also a growing recognition of responsible AI approaches to assess and mitigate or manage AI risks. And research question 1.2 and 1.3 are about the responsible AI principles and stakeholders covered by the different frameworks. So we find that many of the collected AI risk assessment frameworks have a limited scope and fail to consider more comprehensive stakeholders and responsible AI principles. For example, the figure on the left-hand side shows 5 of the collective frameworks did not specify what their guiding principles are, or what they aim to, or what their the principles they aim to address by their framework. And then the figure on the left, on the right-hand side, suggests that 6 of the frameworks did not specify the stakeholders, the stakeholder involved by their framework. So anyway, this can result in certain risks being overlooked and thus left unaddressed. Research question 1.4 aims to unveil the scope of the 16 frameworks, including the AI lifecycle stages they covered, the geolocations and domains or sectors they can be applied to. So as the figure shows, although there are like seven frameworks did not specify their very explicitly specify in which stages or in which AI lifecycle, AI software development lifecycle stages the different questions can be applied. They did throughout mapping. We do find that these frameworks are generally domain agnostic, and they generally holistically consider the entire lifecycle of AI systems, although they may or may not have specified this point. But they do lack clear guidance on how to adapt their frameworks to a more diverse context, because they just usually they would just release this framework and publish this framework and say, oh, you can use this framework. But different organizations or different regions or different countries, they can have different requirements or specifications, and how they can adapt these one of the particular frameworks to their more specific context and organizational background, or this is not not found throughout mapping study. And Research question 2 is mainly about the assessment processes of the frameworks. And before I go into the formal findings, I'd like to introduce 4 concepts first, because this will make things easier and clearer. So we identify the 4 different types of risk factors. These frameworks usually you aim to identify or address. The first one is hazard. It's like it's usually some dangerous situation or condition arising from AI systems, or the activities or artifacts related to the AI systems. As for exposure, we define it as the just elements or individuals or properties or systems, or just really just anything located within zones affected by AI-related hazards. And for a vulnerability, we define it to be the characteristics and circumstances of an AI system or related artifacts or activities that make it susceptible to the detrimental effects of a hazard. And the last one is more interesting, I think, and compared to the first 3 risk factors. The last one is about mitigation risk, or risks by or after mitigation. So this includes this actually includes 2 types of risks. So by risk by mitigation, we mean like you identify some kind of risk, and you introduce some mechanisms or techniques to aiming to address these particular risk. Maybe this particular risk can be elevated or addressed in a way, but then the newly introduced mechanisms may then introduce new risks. And then risks after mitigation mostly mean residual risks that persist even after the implementation of certain mitigation measures. So after the concept introduction, I'll just go right into the assessment process, the results and findings regarding the second research question. So there are 1, 2, 3, 4, 5. Yeah, I think there are mainly 5 findings in this section. I'll just briefly go through them. So the first finding is about the subjective evaluation from assessors, because currently these assessment or management frameworks, they very largely rely on human assessors to filling the questionnaire or to do the checklist thing, to tick yes or no, this kind of thing, and it's also very subjective. And I'll, considering the time constraints, I'll just briefly go through the next findings, mostly the ones I already highlighted in bold. And the second finding is that the frameworks do not clearly distinguish among different risk factors. And the third one is the lack of clarity in specifying the stakeholders, the resource needed for a assessment process to be completed. There are usually like different stages or different steps, and for each step there should be different input, output, or stakeholder involved or resource required at the specific step. Yeah, I'll just skip this because I think you can. The next ones are relatively less important. And then lastly, I'll just dive into the most, I think it's kind of the most important finding or implication for our research, which is a kind of like a map towards more concrete and connected framework design in the future. So of course, there are qualities like connected. So by connected, and we actually mean like, so a framework can be designed to specifically for one principle, like transparency or explainability, and it doesn't involve any other like because for responsible AI ethics principles, they usually are like 7, 8 or 8 principles, but then one framework can be designed to address one specific principle, but then even if it's aimed to be designed this way, it should be like connected or with other. It should ideally be connected with other frameworks that specify that addresses other principles. And also there are different elements to be included, which is covered by the mapping study. And lastly, there are different processes. For the process, there should be. I also mentioned this point just now. There should be so it should be specified by the frameworks that that the different steps required, and the stakeholders and input outputs, as well as the resources needed at different steps. Yeah, I think that's all for my presentation, just giving the time strain. I hope I kind of clearly explained everything. Yeah, thank you.
Thanks, Buming, for the presentation. And any questions from the audience? Thanks, Leo.
I might have a question.
Sure, please go ahead. Yeah.
Buming, thank you for an interesting presentation. I saw that you actually have 2 Dutch risk assessment frameworks included from the Netherlands, and I am from the Netherlands. So
yeah.
Out of curiosity, just one question. I think these frameworks are in Dutch, actually. So how did you deal with translation?
Oh, there is actually one for the Netherlands one. I think they have a they have an English version.
Okay, they already have it. Okay.
Yeah.
I was also
we use the ChatGPT to help us.
yeah. I was also wondering, because I came across this exact the Dutch framework that you are reviewing. I came across the same framework from a different angle, because I was looking at let's say frameworks that specify quality properties of AI systems. So that's basically the opposite of the risk. We could say that if the quality property isn't there, it's a risk. So I was thinking that you might, so maybe not, maybe there are also frameworks that do specify risks in a different way, that you could use as a risk assessment framework, if you know what I mean. So
yeah, I kind of understand that. Just so to answer your question, I think so. This is actually very tricky. So I think your question about the like whether we have covered the proper like risk assessment frameworks like in our mapping study, right?
Yeah.
Because this is actually one of the questions like that's kind of like troubling to us when we were conducting the literature review, because actually the different frameworks, they have like I said, they have different names. They some of them may not specifically say we like include the AI or risk assessment in their names or in the titles. So to do this, we actually have consulted with an internal like we did this so first we conducted the mapping study, the systematic literature review, and we kind of did the slow bolting part to try to include as much as possible like literature we can find, and then based on the results, like the 16 result. It used to be more, we kind of like selected to 16, but anyway. So the second thing we did is to consult with our with a responsible AI. I think she's a standard like she's actually the keynote speaker on Sunday. So already like she's a expert on responsible AI and related policies and standards and these frameworks. So we kind of consulted her to check if double check if we missed any important like frameworks. So that's basically
I will think about this also a little bit more, because I'm trying to establish, let's say, a quality assurance framework. So in the future, if I run into anything related to quality assurance frameworks, they might also qualify as risk assessment frameworks. But I'll let you know if I come into anything like that.
Yeah, thanks for the great input. Time for one last quick question. So if no more questions, let's thank the speaker. Thanks, Buming. And so we have a next talk by Petra. And like she just mentioned, they propose some of the focus on the quality aspect. They propose, I think, in this work, a quality model for a very interesting platform for wildflower monitoring. And the Petra and Gerard from the Fos University of Applied Science, Netherlands. I hope I say your university name right.
Yes.
And without overdue, I pass the token to you. Please go ahead. Yeah.
Thank you. Yes, okay. Maybe it's good to first shortly introduce myself because I have a little bit of a different background. I've been working as a software engineer since 2002. So I realized when making this presentation, it's more than 20 years now. So I didn't realize, I didn't feel like that myself, but since a long time. And since 2004, I started working as a software quality consultant. So not so much programming myself, but yeah, quality assurance in software engineering environments. And then since 2012, I became a lecturer at Fontis ICT, and that's a profession-oriented bachelor level education. So we are really educating software engineers that directly go to industry. So no academic careers, but really working in industry. And basically, I've been continuing with my work on software engineering and software quality. And since 2019, I combined that with the upcoming, we saw that more and more students at our bachelor level profession-oriented university, they started to get assignments to work as AI engineers. So I wanted to research, okay, but what do we need to teach them? What do we need to teach these AI engineers that go and work in industry as software engineers building AI systems? Yeah, what's there for them? What are the practitioner tools or methods, or what should we tell them? So since 2019, I've been basically following all white and gray literature around this theme and trying to summarize or categorize or make overviews of that, focused on what we need to teach our students, but also what we need to teach software engineers that already work in industry and want to start building AI systems. So one of the results is a kind of the picture you see on the right hand side. It's the I try to make an overview of quality properties of AI systems that are not represented yet in the quality models that we know for traditional software. It's the ISO 25000. It has a whole quality model for quality characteristics for software products. But for AI systems, we need to add a number of quality properties. And I'm glad to see that the keynote presentation of Foutse this morning had almost exactly the same list of what is the properties of trustworthy AI systems. To give an overview of what's needed for AI systems. And in the paper we submitted for CAIN, we basically apply this quality model. So we focus on the 9 additional properties to an existing project that we are working on. And that's the, like Sanchang already introduced, the Flower Power Wildflower Monitoring Platform. So the idea of this project is to have a system where biology researchers can easily, analyze the biodiversity of certain fields, for the moment in the Netherlands, but of course it could also be used in other countries if we have it. They do that by making, the current idea is drone images, but could also be with regular cameras, as we have the first test done with regular cameras. Make an image of a field with wildflowers, with blooming wildflowers. And then we have an AI system that automatically detects the blooming wildflowers and also categorizes them and counts them. So this counting is really important. It's not just recognizing individual flowers, but recognizing a field full of flowers and automatically counting, we have that many flowers of that type. And that's an important business case for biodiversity research in the Netherlands, but I guess across the whole planet. And it's my co-author Gerard Schout, and he's more the expert on the flower part and the biodiversity part, and I am the expert on the AI engineering part of this system. So here you see a quick overview of the architecture of the system, but it's, yeah, I think it has a similar architecture as you would expect for many other systems doing something with AI models. So we have annotated images going in. We pre-process, of course, these images because we need to do some tiling. We cannot process these big images at once because we need high resolution to recognize these small flowers. So we need to tile the images. We can train, for the moment, we don't have very complex models yet because that was not the purpose of this first phase. It was just to see if it's a feasible thing to do. Then we have a trained model, and of course you can input new images. You need to do a kind of tiling thing again, and you do inference. Yeah, you get the counts of the wildflowers. And the current stage of the project is that we have like Jupyter notebooks doing the part for training the models. And now we said, okay, it looks like it's feasible to train AI to recognize these wildflowers on images. These are old images. We have better results now. So we think it's feasible. So now we want to turn this Jupyter notebooks experimental AI models into a full-fledged monitoring platform that it's really usable for the biodiversity researchers, biology researchers. And then we realized, okay, that's something else. Maybe we need to start from the beginning and rethink, okay, what's this wildflower monitoring platform supposed to do? And what are important requirements for the platform? And let's not forget the quality or non-functional requirements that are needed. So what we did for this paper, we applied the quality model, which in fact is a list of 9 non-functional or quality properties for AI systems. We applied it to this AI system to see how this works out and if it's a good something that could be done also by other projects. So the first thing that makes this AI systems different from traditional software engineering systems, of course, we all know, I don't have to explain that here. We are training models that learn rules from data instead of that we as programmers program the rules ourselves. So training these models leads to a number of additional important quality properties that we also heard this morning. We want our models to be correct or accurate and also generalized to new data that we didn't choose for training. We might want our results to be reproducible, to trace back of, okay, why was it learned this way? And of course, we want our models to be robust against attacks. So how does this translate to the wildflower monitoring platform? I just included some examples here in the slides. Of course, the full list of quality requirements is in the paper, but just to give you ideas of, okay, we trained the model with some training data that was collected, for example, by Gerard. He was just walking around with his camera around Eindhoven and taking pictures of flowers. So the training data was with very specific, for example, camera types, and in very only a few weather conditions, mainly sunny weather. So we realized, okay, if we really want this to work in a production environment, we need to think about what is the context of our AI model to operate in. So of course, different weather, we need to collect data for different weather conditions and test for that. We need to specify the landscape types because we were thinking about using drones. We need to have an open view of the land. And we need to think about, okay, what does it mean to detect all flowers in an image? So we need to specify some boundaries for wildflowers. They should be blooming, so not the bloom the blooms should still be there. They should at least be 50% visible, because some flowers can be on top of each other, and they should be big enough. And we define big enough as 1 centimeter, bigger than 1 centimeter for the flower head. So these were all things we didn't think about in the experimental phase, but we have to think about if we are really giving AI engineers an assignment to build this system as a production system. Another thing that's difficult for different for AI systems than for traditional systems is that we are usually data sets with all kinds of hidden patterns, where the model is a kind of black box that's going to discover these hidden patterns in the data. We all know, of course, that selecting the data, the right data, is an important part of achieving high quality results with your AI system, selecting the right training data. But at the other hand, we cannot, as a human, check all the data line by line or hand by hand or image by image. So it's a continuous process of doing that. And in this case, of course, the data is images of flowers. I couldn't find this top level view flowers, but these are some side level view of flowers. The problems that arise when using these big data sets that we cannot easily check is that we need to be aware of this. That's also, it has been mentioned this morning, and it's being mentioned everywhere. We need to make sure that the system is fair, that there's no bias in the data, that's a good representation of the real data, and that we preserve the privacy. And then we were thinking, okay, fairness, privacy, this system is about flowers, so we don't really need to do anything about this. But the funny thing is, I discovered in discussing with Gerard, who is an expert in this biodiversity and flowers, he's actually a nature photographer from his hobby, almost profession. He said, yeah, but wait, flowers do have privacy issues and fairness issues. So that was a really funny discovery. And I can imagine that for more projects that do not really involve humans, you could still think about, if you really think about this from a privacy and fairness perspective, you would discover similar surprising results. So because Gerard told me, okay, let's say we have a rare orchid, and we have pictures of a field where we detected this rare orchid. We would like to protect the exact location of this rare orchid, because otherwise all people in the Netherlands will go there, and we might run the risk of ruining the rare orchid. If somebody steps on it, or somebody goes there to take a picture of the rare orchid and ruins the other flowers around the orchid. So it's really, there was really a surprise that even flowers, and also in terms of bias, you want these rare flowers to also be present in the biodiversity overviews. So you want to have, or you want the rare flowers also to be recognized by the system. So you might want to train with them as well. So yeah, even flowers have a right for privacy and fairness. And the last thing, which is new or has been receiving more attention, I would say, in AI systems. Of course, in traditional software, we also had a huge emphasis also on usability aspects and functionality, functional suitability. It's already there in the ISO 25000. But with AI systems, I can see even more attention for this, because AI systems are really meant to take over tasks from humans, or even or support them really well in the decisions that they need to make. So this human-centered AI, how people work together with AI systems, gets much more emphasis. And in our system, it's not just a biology researcher who goes out, takes pictures from a field and gets back these counts. It's also, for example, policymakers who are interested in knowing the biodiversity of their city, province, or area of interest. And we also wanted to, in the future, include an option for citizen scientists to go out and take pictures of flower fields for us, to do a kind of crowdsourcing of pictures. And of course, another user is the AI engineer, him or herself, who needs to interact with the system. But because of this human-centered AI, that we really want the AI to work together with humans to automate or support their processes, we get another 4 important characteristics. We want the collaboration to be as effective as possible. Of course, the explainability, we have heard about that also a lot. We need to make clear to the human on what grounds the AI suggests something or makes decisions. We want also to, in most systems, that's the case for all of these 9 properties. The idea is that you analyze them for your concrete system and see which properties are important and which not. That's the trade-off that you always have to do for quality properties. So that also holds, of course, for AI systems. So controllability might not be an important property in all systems, but at least you should consider if it is important or not. And the human autonomy, that comes from the European Union requirements list for trustworthy AI. Users should not feel threatened by the system. That's also something very important to keep in mind. And for the flower that's where we said, okay, if we want the system to effectively collaborate with these biology researchers, we realized, okay, it's not just like we have in the Jupyter notebook, you upload or you feed one new image to the model, and the model annotates the image with predictions and percentages of which flowers are on the image. No, for an effective system, the biology researcher needs a batch mode where he or she can just upload all the pictures of one field of flowers and have an aggregated table of the counts of all the flowers there. And we realize that controllability is also
sorry to
Yeah.
interrupt. I can give you maybe 1 more minute to wrap up, and we head into the Q&A part.
Okay, yes. I'm almost finished. I had until 10, right? 11:10 or
no, it's 20 minutes including 5 minutes Q&A.
Okay, sorry. Yeah, that controllability was an important aspect. So to summarize, I was almost there. To summarize, we doing this process of applying the quality model as a kind of requirements engineering tool to come up with the right quality requirements. We found out that this works really well and that it can function as a kind of standard dictionary for these AI-related quality requirements. And future work is to build this further with also tools and techniques to actually assess quality of AI systems based on these properties. So that was it. Thank you.
Great. Thanks for the very interesting talk. Any questions from the audience? Please just feel free to unmute yourself.
Hi, Petra.
Hi.
Thank you for such a wonderful talk. I really like your flower. I think it's a really nice way of illustrating all these different components. My question is exactly how you ended the talk. So you were saying that we still need to understand what are the techniques and tools out there. And then my question was actually that, I mean, so as part of the requirements is we need to find ways of verifying and validating these requirements. Did you come across any, how mature is that, and how if you come across any useful sources that could help us expand this flower to ways of testing these requirements.
Yeah, that's actually, I have in the bottom of the current slide, you see the link to my blogs, and I have been collecting everything I found in these blog posts, but the work that still remains to be done is to revisit everything that I found until now and to categorize it in these 9 quality criteria that I have in this model. And I think my hope is that any researcher out there who is working on one of these properties recognizes, okay, my work is part of this leaf of the flower. So maybe now that I'm talking to you about this, I'm thinking maybe we should start some kind of open source wiki-like thing where people can just add their works in the correct leaf of the flower.
Yeah, some sort of collaborative list of awesome tools.
Yeah.
But from your experience, do you think that some of these leaf petals are more represented than others, and which ones are definitely overlooked by our community? Do you have any feeling there?
I wouldn't say that any of the leaves is overlooked, because for sure bias and explainability, these are the main things. We also did some other inventarizations in the Netherlands, and almost always these 2 are mentioned as the 2 most important ones. But I more see the problem in the fact that the current works are too much, let's say point solutions, so they're not aware. So in most studies that I read, the lack is that they consider just one of the properties in isolation, wherein for real trustworthy AI systems you need to consider them at least 1 or 3 or 4 together to balance, to trade off, and we don't have any of that types of frameworks or tools yet. That's
a really nice observation. Thank you.
Yeah, totally agree. Very excellent point made. Raise awareness of this holistic understanding of this quality, different quality aspect.
Yes.
Any more questions? I can allow 1 more question. If no more question, maybe let's thank Petro for the very interesting work. And I really like the system and this holistic view. Thanks, Petro.
Thanks.
Okay, our next speaker is from Leiden and from the Leiden University, Andres and Joost. I hope I got your name, second author's name right. Okay, and just to remind you, this is a Distinguished Paper Award candidate. I don't know the result, but I hope the award come out of our session. Okay, okay. Andrew will talk about the design approach. I personally feels very interesting. A design approach to come up to design a framework to inject these best practices in the AI deployment pipeline. Without further ado, let me pass this to Andres to talk about this very good candidate for the Distinguished Paper Award. Please.
Thank you for your enthusiastic introduction. Can you hear me loud and clear? Perfect. So hello everyone. It's an honor to be here today to present our research on how to encourage the adoption of AI deployment best practices. And first, let's look at why it's so crucial to improve the adoption rate of best practices. So, as we all know, ensuring the correctness and robustness of our AI ML deployments is crucial. Failure to do so can result in suboptimal real-life performance, lack of accountability, missed opportunities for improvement, and even negative societal impact. However, while working on practical use cases, we started noticing a strange phenomenon. Again and again, applying AI for our use cases was surprisingly simple, but deploying these AI services to production seemed unreasonably challenging. So it turns out this issue isn't unique to us, but rather prevalent in the industry. So let's explore, why does this asymmetry exist? So first, let's look at the current state of things. It's easy to just take state-of-the-art methods and pre-train models and use them. It's also relatively simple to specialize models using fine-tuning or lately low-rank adaptation. But on the other hand, using AI correctly and reliably entails much more than just calling a predict method. For instance, we must continuously monitor our deployed applications and incoming data because errors might not be as obvious to detect as in more traditional applications. So what options do we have to ensure the high quality of our deployed models? Let's look at what it takes to deploy a trivial model using Seldon Core. As we can see, it takes a lot, and it doesn't even satisfy many of our deployment criteria. Don't get me wrong, Seldon Core is a powerful tool that can help us achieve great deployments, but the main issue is that it requires careful consideration and time investment, and the amount of time investment needed becomes incomparable when we look at how simple it is just to use these AI wrapper libraries. Before moving on, let's also address the elephant in the room. It's also increasingly easy to imagine relying on models over which we have very little control. Though this doesn't change the fact that we remain responsible for our applications. We must still ensure that we have the necessary tools and infrastructure in place to monitor and interpret their behavior. But yeah, let's go back and see what exactly are these deployment best practices. For instance, in the paper, Adoption and Effects of Software Engineering Best Practices in Machine Learning, the authors compiled 29 actionable best practices, such as logging production prediction traces or versioning data, models, configurations, and scripts. They also conducted a survey to which 313 ML professionals had responded, and we can see the results on the left. Over 3/4 of newcomers to AI reported that they partially or not at all followed best practices. This tendency decreases with more years of experience, reaching a maximum adoption rate of just above 60%. However, this is still way too low. Similar surveys have shown the same trend. As prior research concluded, there is a need to consider and adapt well-established software engineering practices which have been ignored or had a very narrow focus in ML literature. We fully agree. The strange situation is that there are already solutions to mitigate suboptimal deployments. However, mounting evidence shows that these remain largely underutilized. Why is that? Let's look at some of the available options when it comes to better deployments. AWS's SageMaker and the before-mentioned Seldon Core are easy to recommend, at least when enough expertise and motivation are available to meaningfully take advantage of their features. Because the former requires introducing the cloud as a dependency, which is straightforward for some projects, but not for others, while the latter requires in-depth knowledge about DevOps and MLOps technologies. In summary, while surveys and case studies have shown the industry's continuous struggle to evolve prototypes into robust and responsible production-ready deployments, platforms aiming to help overcome this challenge lack widespread adoption, as indicated by the same survey results. Could perhaps ticking all the boxes have increased the adoption rate of best practices in the industry? We hypothesized, yes, we hypothesized that facilitating the adoption of AI deployment best practices is viable by finding less complex to use framework designs that are therefore easier to adopt in order to decrease the negative externality of misused AI. So to test this, we designed and developed the Great AI framework. Mainly, not to be an end-all be-all solution, but to prove the principle's feasibility and effectiveness for designing ML deployment frameworks with ease of adoption in mind. Thus, the goal was to find and validate patterns we could use to minimize the required effort for adopting the framework, while at the same time maximizing the deployment quality it provides by default. Throughout our investigation, we followed the methodology of design science. You can see the design cycle on this slide. And its point is that it emphasizes the need to design and investigate artifacts in their contexts. The context, in our case, was the design and implementation of 2 industrial ML applications. While solving the problems, we iterated on the framework's design and continuously retested it in practice. So the best practices we aim to support are a subset of those compiled in prior art, namely the 3 pieces of research shown on the right. But also their importance and potential to be mostly implemented by a software framework. For example, we strove to make it general because we want our framework to be compatible with a wide range of AI libraries. But we also didn't want to ignore robustness. Errors can and will happen in practice. So storing and investigating what has led to them is required to prevent future ones. Being end-to-end and automated is also crucial, and we'll touch on these later. And last but not least, great AI also needs to facilitate trustworthiness. As detailed in the ethics guideline for trustworthy AI, human oversight, accountability, transparency are all key requirements for trustworthy AI applications. You can find more explanation on the followed design principles in the paper. In short, we aim to create a simple, deep, yet transparent API. In the paper, we don't go into the exact details of the case studies, which were conducted in collaboration with a Dutch startup called Scout & Science. But in short, the case studies focused on individual components of a growing commercial platform, which aims to find tech transfer opportunities in academic publications. So the primary input of this system as a whole is a set of PDF files, while the output is a list of metrics describing various aspects of each paper. The results include a predicted score for ranking, and this ranking is subsequently processed by the business developers of technology transfer offices of Dutch and German universities. So overall, this practical problem context carries the properties of typical industrial use cases. It utilizes a wide range of methods, contains complex interactions between services, benefits from integration of end-to-end feedback, and must provide the clients with a platform that they can rely on within their organization's core processes. So after refining the framework with feedback gathered from these case studies, we ended up with the following core architecture. The expected client project and the actor integrating it are highlighted. In short, the architecture is fairly simple, yet extensible. The general theme is that each best practice has its distinct, loosely coupled functions or classes, and when collaboration opportunities arise, such as persisting model versions into prediction traces, there are 3 primary conduits for realizing them. The context object, responsible for global configuration per process, the function metadata store specifying expected behavior of each prediction function, and the tracing context created anew for each prediction session. But that's enough of the implementation. Let's look at what Great AI and its design actually provide. So we compared the features of our framework with the best practices found in literature. You can see each implemented best practice in the table with an associated level of support next to them. So double check marks mean fully automated support, single check marks denote support, while the tilde sign refers to partial support. For instance, log production predictions with the model's version and input data is fully supported because by default, it is automatically implemented when calling greatai.create. Users can still specify the exact expected behavior. Nevertheless, the best practice is already implemented reasonably well without user intervention. But for example, use static analysis to check code quality is only supported because even though the entire public interface of the framework is correctly typed, if the users do not use type hints in their code and it contains more complex control flow, it can only be partially type checked. We also highlighted 6 additional best practices, which are generally well-known software engineering considerations that are also applicable to AI/ML deployments. These hadn't explicitly made it into the aforementioned surveys, but we thought it would be nice to include them. So to summarize, the design implements 17 best practices with a fully automated support. And it also implements 16 others with less than fully automated support. This proves the feasibility of designing simple APIs for best practice injection for decreasing the complexity of correctly deploying AI services. To see it in use, we can see that we only added a single new line of code. We started the app through the CLI. Now we can send some HTTP requests for our inference function, and we can see the dashboard that we get by default, showing all our previous predictions. We can search them, we can look at the errors, we can look at certain metrics, we can customize everything, and we get all this just by adding a single new line of code. Of course, detailed documentation is also a must-have. So feel free to check out the docs for more details about the best practice injection and an in-depth discussion of the API. Finally, having implemented a prototype, we must also verify that our assumptions hold true and users really prefer the API styles and features we came up with. So we also conducted interviews with a mix of professional software engineers and data scientists with a vast range of backgrounds, from startups through consultancies and government organizations to research companies. 10 engineers and researchers participated in this study, albeit this sample size is rather small. It still represents a wide range of organizations. We aim to mimic real-world usage and then had in-depth discussions with each interview lasting for about 2 hours. So the interviewees first were asked to answer some questions, allowing us to evaluate our framework against the technology acceptance model. So this model had been widely applied in literature, and due to its general psychological origins, it proves to be effective in most areas of technology. We used its parsimonious version and asked participants 9 questions about their experience using Great AI. So overall, the perceived utility and intention to use components were especially high, with 6.1 and 6 point out of 7. Meanwhile, the perceived ease of use slightly lagged behind. More interestingly though, we observed strong correlation between the intention to use and both perceived utility and perceived ease of use. However, we did not observe significant correlation between the perceived utility and ease of use components. So this validates our hypothesis. Utility and ease of use are nearly equally important when it comes to adoption. Our design has fared well in all 3 components. We also noticed feedback during and after the task-solving parts of the interviews. And after conducting thematic analysis on these, we got the following overarching themes. The feature set was rated mostly positively, especially with the automatically scaffolded REST endpoints and support for deploying notebooks were some of the highlighted features. When it came to the API, the reception was a bit more mixed, with some users missing MATLAB support, but in general, they appreciated the approachable nature of the API. And lastly, most participants had also raised the question of whose responsibility is it to adopt best practices, because in their experience, real-world projects often include many researchers and experts from various fields. but software engineers are not always prioritized to be included. And of course, doing software engineering without software engineers is kind of difficult. So this framework and its design can also raise awareness, especially by presenting a value proposition that has lower maintenance costs and better long-term quality. And it might prompt users or technical decision makers to invest more in software engineering in AI/ML projects. So of course, there is still more to be done. The primary purpose of the library was to serve as a proxy through which its design decisions could be tested and evaluated in their practical context. However, due to the nature of the case studies, much attention had been given to NLP, which might have resulted in overfitting the library to this use case. And even though we have given much consideration to finding a diverse and representative set of interviewees who could meaningfully evaluate the framework, of course, we could have found more interviewees and conducted more in-depth interviews, which could possibly uncover more areas and hard edges that should be addressed for maximizing adoption and usefulness. So these are certainly options that we would like to consider in the future. But for now, to conclude, we think that software systems are like a puzzle, and it seems that to basically all engineers, a new type of puzzle piece has just been made widely available. But it's a complex and nuanced one, which behaves unlike regular software components. Thus, without proper guidance on how to fit it correctly, grave mistakes can happen. We have learned that AI deployments in the industry don't always follow the latest best practices, and existing deployment frameworks don't always make it much easier, even though they could. So we created a framework to prove it is feasible and worthwhile to have AI deployment frameworks automatically inject best practices. And this not only results in objectively more robust and reliable and trustworthy deployments, but also better developer experience and therefore a higher likelihood of adoption. We can hope that with higher adoption rates and more deployment best practices implemented, will come more improvable, explainable deployments, which will better mitigate potential negative societal harm. Thank you for your attention. Do you have any questions?
Thanks, Andres, for the very interesting work. I see the Leon actually raised the hand, and also the Petro. Let's maybe Leon first.
Hi, thanks, Andres, for this very nice presentation. I think this tool sounds really cool, but I was wondering what actually is the runtime of this tool? Like, does it work with clustered environments like Kubernetes?
Mm-hmm. Yeah, so I didn't go into the implementation details, but basically it implements a decorator pattern. So if you have your model and it can run anywhere, it can run on all existing ML deployment solutions, or maybe it uses MLflow, but still it has an entry point, and you can wrap this entry point with this framework that we provide, and that will automatically augment it to try to have it implement as many best practices as possible.
Okay, maybe so I think I didn't really understand it, but this, your tool still runs like in one containerized or in one environment, but is it like able to utilize the container orchestration architecture of like clustered environments with many recent applications are built in with like microservice architectures?
Of course. It was one of the main design goals to have it be deployment agnostic, so it doesn't matter whether you use container orchestration or whether you have it run on a single machine. We provide an interface that works with both of these approaches. Of course, the main takeaway of this research is not that everyone should immediately start using great AI, even though it's kind of neat. But the main point is that the design patterns that we use are actually feasible to use in practice, and they could be integrated into existing solutions. Because I really believe that, for example, Seldon Core is a very neat deployment framework for AI, but it could be improved. And it was a lot easier to create our own toy framework and try out all our ideas than to go into the Seldon Core code base and start messing around. Now that we know that it actually works, the next step might be to, for example, include these patterns into existing frameworks.
Okay, thank you very much, Andreas.
Petra?
Yes, thank you for your interesting.
Try to make it short.
Make it short. Okay. Yeah.
Yeah.
Okay. Bottom line of my question is, I'm interested in your future work around extending this to other AI lifecycle phases, etc. But it's not really clear to me what's the role of this future work of Leiden University versus Scout in Science and your personal role.
Mm-hmm.
Could you explain that a bit more?
Yeah, so I will leave the future work to my co-author Joost and also the SAFORML research group at Leiden University. So they have been doing great work in this area, and they will continue to do so. I'm not pursuing a career in research. I'm actually in London right now, working for a different company. So for me, it's not super relevant. But yeah, I appreciate the question.
Yeah, but the tool now is online at Scout in Science, but...
Yes, it's an open source tool with a GPL3 license, so you can feel free to check it out and use it. And I especially recommend the documentation. It has lots of examples on how to use it, but also what it does under the hood in order to inject the best practices. So I think it's a worthwhile read.
Okay, thank you.
Great, thanks, Andreas, for the very nice presentation. Also, the very useful tools potentially. And let's then we have a last talk by Leon. He will talk about the towards code generation from BDD test cases specifications, a vision. And this is also I believe, very interesting topic, and could be very useful and for automate some of the software development steps. Please go ahead, Leon.
Thanks, and thank you all for joining this presentation about our vision paper towards code generation from BDD test case specifications. Now, these are the authors of the paper, and I'm Leon Chemnitz. Okay, first to our agenda. In the beginning, I'm briefly going to talk about the state of the art surrounding this research. And then I'm going to talk about our vision, and then our plans on realizing that vision, and in the end, a bit about the potential impact that this research might have. So, first of all, as you all probably know, automated software testing plays a big role in software engineering, and there exist actually many approaches that aim to integrate AI and software test automation. In this here graphic, you can see the testing activities that aim to integrate AI plotted against publications or the amount of publications that aim to do that. This is based on a 2020 literature review, and as you can see, most of them aim to generate tests, from code or test articles. And what we want to do is kind of the opposite and generate code from tests. And another finding of this literature review was that the most reported benefit of using AI is manual effort reduction, which is also our intent. Now, also the realm of software testing is very large, and we want to focus on a specific part of that, which is behavior-driven development, or BDD in short. And BDD evolved from test-driven development. And the idea of it is that, at the beginning of software development, tests are specified, and these tests are specified in a ubiquitous language. And this term, ubiquitous language, stems from domain-driven design. And the idea is that it's a language that is not only understandable to software developers, that are used to code, but also to domain experts and maybe even stakeholders. And how would something like this look like? Well, here on the right, you can see an example of a BDD test case specification. And if you can see, it says feature, change password, scenario, change my password, given I'm signed in. When I go to the edit user page and I fill out change password section with new password and so on. And the idea is, even though some of you probably even don't know what language this is, I think all of us could understand what this is specifying or what this is trying to, accomplish. And so it's understandable like natural language because it includes natural language, but it also integrates the special syntax and these keywords that make it processable by automated tools. And in this case, the Cucumber testing framework. And there actually exists an approach from 2012 that aims to generate code stubs from these BDD specifications, and they were using the natural language processing techniques of the time. But as you all probably know, natural language processing has evolved quite a bit since 2012, and now transformer-based language models are basically everywhere. Ken gave a very nice introduction to transformers in his talk yesterday, so I admit doing this now. But they've also been very successfully adapted recently for code generation. So there have been lots of approaches that aim to do that. Most notably, maybe Codex, which was then also used in GitHub Copilot, which probably many of you have heard of or even used. And also more recently, Starcoder by Hugging Face. And as you can see, like the pace at which this research is conducted is, very fast, and one could argue even maybe accelerating. If you have a look at the timestamp of this most recent contribution here, being Starcoder, then I think everybody gets a sense of the amount of research that is done in this field. But all of this research is done by very large software development companies, and why is that? I mean this is only speculation, but these companies, they all develop software, and if there is some tool or something that makes the process of software development faster and their highly paid engineers a bit more efficient, then this directly translates for them being more profitable. So I think it's fair to say that there's a high interest from industry in this form of research, But basically, all of these are various forms of auto-completion or code generation from prompts, if you think like ChatGPT or something. And now, but what is our vision? Our vision is to achieve a higher integration of AI in the software engineering workflow, like higher than just auto-completion in your IDE. And how do we want to do that? We want to do this by taking like these BDD test case specifications and turning them into actual software components or application code. And why do we think that this is maybe a valuable idea to pursue? Well, first of all, these BDD specifications, they contain a lot of natural language, which language models are obviously very good at processing, but they are more concise than natural language or like prompts that you might give a language model. And since they are actual specifications, we think that they contain a very high degree of information about the desired output that is to be generated. And we think that this can be leveraged in the generation of code for better generation results. And we think that this can be used to combat some of the most prominent issues that current approaches might have. Mainly, we think that it can combat the misalignment of user intent with the actual generation results. Like, for example, you might generate code with some of these tools, and the code looks like good, but only superficially. And in the end, it turns out it didn't really do what you wanted to do. And it's also something that was pointed out in the original Codex paper. And we think this way, one can build more trust in the generation results, because like, how do you build trust in code? Well, you test it. And if you write the test before the generation and the generated code satisfies the test, then you have you can trust the code to a higher degree. And our big vision is to build like a general purpose solution that is applicable to many languages, many frameworks and use cases, but this would pose like a very broad research task. So instead, for the immediate future, we want to focus on a very specific environment and focus the feasibility of the approach there. And the environment we chose was the Angular web front-end framework. So basically, it's a framework for building web applications, so applications that run in your browser, websites essentially. And why did we choose that? Well, first of all, Angular is a very popular front-end framework. So if this approach were to succeed, then the results would be relevant for many people. Also, we think because of this, there are potentially many examples of high quality training data on public repositories. Also, Angular is very opinionated, so there exists a lot of conventions. It's a very on Rails approach, and we think this should make it rather straightforward for the model to pick up on these conventions and generate high quality code. And most importantly, it enforces BDD. So the way Angular works is it allows you to create components. So code is structured in components, and components basically are like a reusable piece of UI that can be arranged hierarchically with other components. And for every one of these components, there exists a BDD specification. And here on the left, you can see an example of what such a specification might look like. It's not doing the exact same thing as the example I showed you earlier, but it's doing something similar. And our idea is to take this and then turn it into actual Angular application code. And how we want to do that? Well, first analysis has shown that there are around 400,000 GitHub repositories public that use Angular, and contained within these repositories, there are around 2.5 million potential test pairs. So specification plus component pairs. Now, this is really raw and unfiltered data, so the amount of usable data is probably orders of magnitude less, but this still is like a pretty good indication that there is a fairly large amount of training data that we can use. And then we want to use state-of-the-art models, whatever the current state-of-the-art is at the time, to train on this data. And then at inference is maybe where like the key of our idea comes into play, because as I said, the generation input in itself is a specification, and we think that this can be used at inference for better generation results. And we think there are various approaches. Like the simplest would be to just sample from the output using like whatever decoding strategy is, the current state of the art, and then take the K most likely results, so the 1,000 most likely results, and run them in a sandbox against the test specification that we have, that was our input, and select the sample or that satisfies all or most assertion criteria defined in the specification. And something similar has been done in AlphaCode, where they also use this to improve generation results. Or we could also do something more elaborate maybe, and use reinforcement learning and use like the satisfaction of an assertion criteria as a reward signal. Or we could also maybe integrate other forms of reward signals, like maybe results of static analysis. Like if there are code smelt by some static analysis tool, then this could be like a bad reward signal and inhibit this type of generation. And something along these lines has like the use of reinforcement learning in this scenario has also been done last year in a paper called RL. And now to what potential impact this research might have. So if you are in this full BED scenario and the specifications serve as acceptance criteria, then after the acceptance criteria would be fulfilled immediately after this specification of these tests, you know. So this would obviously imply very huge time savings, because like basically all of the initial programming work would be automated. But even if you're not in this full BEDT scenario, we think that it still could impose very large time savings. And what we also think is that it's something that would incentivize developers to adopt good software engineering practices. And why do we think that? Well, maybe I think most of us at that point in their life have come across something like this. But you know, in projects, especially when they are you know, on a tight timing budget, as they oftentimes are, developers oftentimes choose to maybe not write as many tests as they maybe should, because you know, writing tests doesn't give any immediate benefits in terms of like actual application functionality being implemented. But there's still, as you all know, a good software engineering practices. But now, if a rational developer were given a tool that allows them to work faster, because a lot of their work can be automated, and this tool needs them to write tests beforehand, then you know, because it's faster, the rational developer would maybe go that route. And so, in a way, we think this would lead to higher adoption of good SE practices, and is maybe a way to even you know, improve software quality. So thank you all for listening. If you have any questions, you may ask them now. But since this is a vision, general feedback or recommendations are also, you know, highly appreciated. And I'm also going to be there for the on-site portion of this conference on Saturday. And I'd be very happy if this could spark some interesting discussion with some of you. Thank you all for listening.
Great, thanks, Leon. I would say this is a great vision and the right direction we should explore. But maybe I'll ask a quick question first. On the right corner, you just mentioned, are you already providing or collecting a data set to explore this vision?
Yeah, that's like the current step we are at. So first, you know, we had this vision, and we first, you know, hear feedback if some maybe even think that this is valuable pursuing, and now we are actually, you know, doing the MSR task of mining the test and training data.
I see. Just curious, because this is very interesting. I guess this is a vision, this is your ongoing work, so you're not ready to release the data set, right?
If it's ready, then we're going to release it, right? But we're not at that point yet.
Understand. Okay. Any questions from the audience? Any questions? No question. Maybe I ask one more question. So from your, because your input is kind of like a Jerkin style BDD test case descriptions, right? And how do you get? Is that really popular in the GitHub repositories?
Well, you know, Cucumber and Gherkin, that's, you know, not as popular, I think, but we haven't really looked into that. Mm-hmm. But we don't want to use for like this first prototype, we don't want to use Cucumber as a framework. But you know, Angular ships with its own testing framework, which also employs a form of behavior-driven development, you know, which is similar to Gherkin. So it also integrates this natural language aspect. So yeah, we do not use Cucumber now, but this would be like the big vision to then you know, integrate with tools like that.
Okay. Last chance for anybody ask to question. If you have questions, also I think we still have a few minutes. If you have questions to Leon or to other speakers, feel free to ask. Okay, if no questions, let's thank all the speakers. Excellent talk, excellent research. Got a lot of inspirations from you. And then this conclude this session. I think next session start at the local time 2:15, yeah, about 20 minutes from now. Don't miss the next session. We have also a lot of a few interesting, very interesting and great papers in that session. Thank you, everyone.